Assalamualaikum warahmatullahi wabarakatuh. We are from Group 4. Tonight we want to present about our project, which is a stone project assignment. For introduction, first, Geographical Information System or GIS, program that facilitates the processing and analysis of geography information by showing geographical statistics. ArcGIS is sophisticated mapping and geographic information system. Lastly, ArcGIS produces map that involves category structure as layers. For objectives for our project, therefore, the first is to understand the basic of ArcGIS. Second, to learn the type of data ArcGIS system. Third, to get data for we can image using ArcGIS. Four, to find factor that causes house damage using ArcGIS. Okay, thank you. And I want to pass for next presenter, Aneka Dao.
Okay, thank you, Fahmi. Next, for my part is methodology of this project. So there are 9 methods that we use for this project. For the first step, which is from step 1 until 3, we need to get a before and after storm imagery from the storm project folder that our lecturer provided. Then a map and record the house damage using the imagery and on the scale from 0 until 10, and we consider this as a dependent variable. If the scale is on 10, it means the houses destroyed or gone, while 1 until 9, it means can visibly damage, and 0 will display no apparent damage. Okay, next. Next, for step 4 to 5, we need to measure the distance of each houses to the storm eye landfall location. In this method, first we need to create a storm center file using Notepad in the ArcGIS software. Then go to the start menu button, click all program, go to accessories and click Notepad. For the step 6, we need to create X and Y data. X and Y data is the location where the storm center made landfall on the coast. Then we also need to measure the distance from every houses to the center storm and put the value into the field which is called distance center. Okay, next for step 7 to 8, we need to find the percentage cover of each land, use land cover, which is LULC types that falls within a distance of 10 meters from each houses. In this case, we need to make a buffer distance to 50 meters. Besides that, we need to convert the LULC layer into vector, then open the spatial analysis toolbar, tap view, click toolbar and spatial analysis. Then choose the spatial analysis, convert raster to features. Next, we go to Arc Toolbox, then Data Management Tool, Projection, and Transformation Features to project, and then make vectorize LULC as the input file. Then to make the output coordinate system, choose import and select the house group number .shp file. Then click OK. Then next, it will let the visualize the various color for each LULC type. So the purpose of this is to obtain the numerous LULC values surrounding each houses and coordinate them simultaneously with the FID number from the buffered houses file within the attribute table. Okay, last for the step 9, we need to find the elevation value for the top of each house's point by using LiDAR data. We need to find the value from the top of the houses in the LiDAR imagery using identify tool, then click the pixel value. We can use the tools in spatial analysis, then extraction, then extract value to point that make the project easy to conduct. Okay, that's all from me. Thank you.
Thank you, Anelka. So my name is Muhammad Shazwan bin Saidi, Nometry 208593. So I will continue the presentation for the result and the discussion. So in this section, we use our data to compare between the damage, which is the damage scale, and the houses factors. For the damage, we scale the houses damage from 1 to 10, which is the more damage the house taken, the higher the scale value, and the less damage taken for the houses means that the less scale value. In this experiment, we choose 4 factors to compare with the houses damage, which is the distance of the houses from the shore, the distance of the houses from the center of the storm, the houses height, and lastly, the elevation of the surrounding land. So for the result, we export all our data from the ArcGIS application into the Excel to make a chart based on our data. Then we take the average value for each factor and relate it to the damage scale of the houses. Next slide. So this is the data for the distance to the shoreline. So based on the average data, we plot the chart of a damage scale versus the distance from the shore. So as shown in the slide, the houses with fewer damage scale has the higher average distance from the shore. Means that if the houses is far from the shore, it take less damage. And houses with the higher damage scale has the fewer average distance from the shore, which means that the house that closest to the shore has more damage taken. So we can conclude that the higher the distance from the shore, the fewer the damage taken for the houses. So that's all from me. I will pass to Azlan.
So thank you, Sazwan. My name is Azlan Bibaka, metric number 208471. So in my part, I will explain another factor that correlate with house damage, which is distance to storm eye landfall location. So storm eye landfall location is the place where the first storm actively happened. From the data, we plot the chart average distance from center of the storm BS versus damage scale, and we make the table. So from the table, houses with low damage scale has the higher average distance from the center of the storm location. Meanwhile, houses with higher damage scale has the lower average distance from the center of the storm location. So it means that higher the distance from the center of the storm location, the lower the damage taken by the houses. This is the same reason like a distance to the shoreline, which is the storm can damage the house which live near the storm itself and damage it compared with houses that live far away from the typhoon or from the storm. So another factor is elevation of top of the houses. So this elevation top data were taken by the LiDAR and analysis using ARC GIS software. So we plot the data and make the graph which is average houses height versus damage scale. So from the data itself, houses with lower damage scale has a higher elevation height from the top of the houses. Meanwhile, houses with higher damage scale has the lower elevation height from the top of the houses. It means that higher the elevation from the top of the houses, the lower or the fewer the damage taken by the houses. So this is because the houses that was built high elevation could reduce potential to be attacked by the flood itself, which is the effect from the storm itself. This flood could potentially damage the houses compared with the house that live on higher elevation. So furthermore, another factor that could we can correlate with house damage is elevation of the surrounding land. So from the diagram below, it was taken by the LiDAR method, same like before factor. So the deeper the color of LiDAR means that higher the elevation of the surrounding. Higher the elevation from the surrounding, higher the damage taken by the houses. So this is because atmospheric water tendency to heavy rain when air mass is lifted and cool when it's reached a mountain range. So heavy rain could potentially damage the houses on the higher elevation of surrounding. So the best the best thing we can conclude that best factor that correlate with the houses damage is distance from the shoreline is the best factor that we can correlate to house damage. Compare with another data or table from other factor, shoreline is more clear result to being correlate. Another result has a minimal differential. The reason is if the storm is coming toward the land, houses that built near the shoreline will contact first and damage it. For safety, better built house for far away from any lake or beach for any natural disaster to happen. Higher the distance from the shoreline, fewer the damage taken by the houses. So I will pass with the Fahmi again.
Thank you to Azlam for the discussion and result. For the conclusion for our project, we have learned and understand how to use ARCGIS is housing damage distance to show, distance to stone eye landfall location and elevation of the surrounding land. Next, we learn the type of data in ARCGIS system. For example, is a attribute data can be stored as one of 5 different field type in a table or database. Which is a character, integer, floating data, and BLOB. Also, as mentioned before, distance for shoreline is the best factor that can correlate to house damage. Thank you.